For transformations, this part, you can do a lot. We'll start with these 4 where we'll move, rotate, scale, and scale in different directions. So scale, it's like scale 1D in Rhino. So here in Grasshopper it's called scale NU. Start with the first one, transform move. So I'll take this same rep, move it down. I'll unit Z with a factor of 25, and you just have to type in move. So when you type in move, you can put it under motion, Z, to go up, and take that rep and put it in geometry. And this is where you have your move. For rotate, we'll go here and same rep, the one we started with. You want to type in rotate. So that goes into geometry. What's your angle? Let's start with a different angle. And lastly, we need a plane. So because right now the plane is default to 0, which is the 0, 0 plane in Rhino. If we were to move there, you would see it there. So this is the plane for this. But there's no object, right? So you need to set the object starting point the same as this. So there's 2 ways. You can either type in plane, set it to here, but if you move this object, it will not be the same exact center and it will not read well. So what you want to do is type in area and put the geometry. And this will extrapolate the area and make a point. So area of geometry, here's your number, but you also get the centroid of the object. So the centroid is just a point, and it will make the center of the object the same as the plane for this module. That way, when you rotate it, you're rotating it there and not somewhere else. As we learned earlier, the rep, same, and the area is the same, because it also needs here for scale, it needs a center. The way that we scale here, where we can just put a point wherever we want. So if I were to, let's say we create a different geometry. Here's my beginning geometry here. Here's my center, right? And let's do scale. Geometry here, center here, and factor. So right now it's huge. So this is straight in the center. We could also either do point, and I can set 1 point here, and it will scale whatever other direction from the point, the way that we scale in Rhino. A little more manual. For scale NU is very much the same as what I just did with scale, is that for everything is divided into its own axis. So if I were to do this, and I set this to 1, this to 1, this to 1, it's the same as scale. So this 2, now it starts deforming one way, so it's kind of like scale 1D. So this one, now everything's scaled sideways but not up, and this one terminates it to the regular scale command. But you can keep going and create something different. For this one, be doing an array that then rotates. So for example, this one, I will just, and I will set this over here, set one rep, now here. So as above, bounding box will help contain the object into its own little box. For reference, type in array, so you can do a lot. You can do box array, but for now I will do regular array, and it's right here in transform. So let's give it a number, whatever number we want of items. Our regular rectangular array. And then we need a geometry. So everything is the same right now, because that's just a regular array. But we will be adding the rotate transformation, which is this simple one. Making it slightly more complex here to get a gradient the way that we have here. So to rotate, we need the center of each item, right? So again, to plane, coming from geometry. This is my relay, right? So this is just so I can organize things a little nicer. If I double click, then I have range, and I also have construct domain. There it is. So my domain could be just 1, but right now I want it to be in between 5 and 182. I mean, it's very specific. It can be whatever you like. And I'm putting it in angle, because I want my angle to not just be 5, right? But then I also might want my angle to my, so this is how many steps. So this is list length, and it will, so instead of telling it it's a 5 by 5 array, or it's a 5 by 10 array, I want it to extrapolate the number that I have already for my array and put it into the steps. So that way I don't have to do double work, and it can change however many times I want. So see how now this centroid is mapping into each one. So this will give me the actual angle numbers. I want it to start in number 10 degrees. So this is the first row. And I want the last row to end in 100 degrees. And lastly, we need geometry to go into the rotation. See how all the cables are very messed up? Now I can see this cable. I also should be a little bit more, I should fix this a little nicer. But now you see everything very jumbled, so make sure that everything is off. So the reason why they're kind of jumbled is also because the angle is not set to degrees. I want it to set 2 degrees. So now you can see. And the reason why you have this where it looks mirrored is because degrees don't end in 100, right? It end in 360. So I will double click, right click, edit, and set it to 360. And now I can see each row kind of take its own degrees, or make it so gradual that you don't see the full rotation. Lastly, for transformations, this one has everything combined. So all these 4 plus 1 more. This one is rotate 3D, which you've done in Rhino. It's the same as in Rhino. So each transform has gotten slightly bigger as a script because of the amount of degrees that I wanted to give it. Let's start with this. This input so you can kind of see. This is the tower that we're creating. So this this transformation is just for up. So all these you can kind of use in combination since everything is going to the last point. Scaling transformation, same range and construct domains, and then same scale output, so you can mess around with the scale of the tower. The rotate, you can rotate gradually or you can rotate a lot. Let's gradually rotate, and then it also rotates this way. So this is just for its bendiness. This does it in all 3 directions. And lastly, scale and use. So this one will give you a scale for each part of the tower. Each side. And then that's the one that you would bake, because that's the last transformation. If you don't want that transformation, then you can bake this one, and it's not as fun. It's slightly smaller. There we go. So all these, you can actually move all these to one area and mess with them all at the same time if you wanted to. And you can group them if you wanted to as well. Right click group as you have them selected. Then you can kind of move them around all together. And lastly, I wanted to show, so this one, the move command doesn't need an area of where it's gonna move from, so that's the only one that doesn't get that. But so it goes to a relay that's straight from the brep. The brep instead goes into the area for the rest of the transformations, because they all need a center or a plane to connect to. So then there's the area module. You only need it once, because once it's already mapped to this, then you can just continue it and relay it into each. The beginning geometry, you can mess around with this, but this is the amount of steps. So this is how many times it copies itself. That's why there's a range on every single script. That way you can control the group altogether. And then the construct domain is just for the amount of degrees or the amount of change that you have to make. The way that range and construct domain work, you can kind of see it here on the right as an example panel. This is the start, and then the amount of steps, and the end, what you would see once those steps are taken through that module, and what comes out the other end. So this is 0 to 5. It's kind of like having this bar that says 25, and let's say you gave it a limit of 25, so 0 to 5 and everything in between. For the number of steps, it's just like an array, how many items. This domain corresponds with this domain, and then the range is this, so whatever is extrapolated from this, all the numbers in between, what they could mean for the rest of your script. For this component vector xyz, so it's kind of like unit x, except for instead of having just one option, you get various. So it's able to kind of construct a change in position in all three at the same time instead of having to rely on just one. You can kind of see it here. If I did this and this, right now it's there. You can kind of see it here if I went like, what is the 0, 0, and it's the same. But because we have all the other numbers together, it will construct everything in a more gradual position instead.